Number 1, a group of students voted on 5 after-school activities. The bar graph shows the number of students who voted for each of the 5 activities. How many students chose activity 3? So you don't have to do any calculations on this one. You just have to show that you are able to read a bar graph. Now we're wanting to know how many students chose activity 3. Well, down here, these are our activities, and there is activity 3. So this is the bar that we want to be looking at in this bar graph. And so once we have that as our bar that we're looking at, let's look where it's at. Where is that bar hitting? How many students are we talking about? Well, we can see that it is between 35 and 40. We may not be 100% sure if that is 38 or 39, but we know it's somewhere between 35 and 40. So if we look at our answers down here, there is only one answer that is in that range, and that is B, 39. So B is my answer. Number 2, what percentage of 300 is 75? There are several ways that you can do this. I'm going to show you several different ones, and you can decide which one is right for you. Also, we want to know which one is the fastest for you, because on the SAT, speed is king, and we want to make sure we're going through the problems, especially these early ones, which tend to be less calculation intensive, as fast as possible. So to do a percentage, it is a fraction, which can be changed into a decimal or a percent. They're all interchangeable. So 75 of 300, there's our key, of 300. That means that 300 is on the bottom in our fraction, and 75 is going to be on the top. So what percentage of 300 is 75? Then that's where you put them. At this point, there's a couple different things you can do. You can take out your calculator and you can type in 75 divided by 300. And the decimal that you get is going to be 0.25. And then you go, okay, that is the same as 25 hundredths. And 25 hundredths, you know this in your head, is the same as 25%. So my answer is A. Another way you can do this, which is equally correct, equally viable, it's all personal preference, is you can think of it in that hundredths right off and go, okay, well, I know a percent is out of 100, and say, what percent is this? And go, well, to get from 300 to 100, I divide by 3. So how would I change 75? I would divide by 3. What's 75 divided by 3? That is 25. And again, I would still get that same answer, A, 25%, because 25 hundredths is the same as 25%. Again, both of these are right. I'm just trying to show you different ways to do it, so whichever is most comfortable for you, whatever makes the most sense for you, whatever is the fastest for you, that's the way you should do it. Any way you do it, A is your answer. Number 3, x squared over 25 equals 36. What is a solution to the given equation? Okay, this is a solve for x, and I'll show you the proper way to do it, and then I'll show you my weird way that I do it, because I'm almost allergic to using a calculator, and I try to figure out ways to do it quickly without. So stick around if you want my little bizarro brain way of doing this. But the more normal way, the way most people are going to do it, is to say, okay, to solve for x, we need to undo what's been done to x. What's been done? X has been squared, and then it was divided by 25, and we got 36. So let's undo that. The opposite of dividing by 25 is multiplying by 25. So I'm going to multiply both sides by 25, and I'm going to get x squared is equal to 36 times 25 is 900. Then x was squared, so to undo that I need to square root, and I need to do that to both sides so it stays nice and balanced and equal. The square root of x squared is just x. Let's put that in blue to be consistent. There we go. And the square root of 900 is either positive or negative 30. And since they're saying what is a solution to the given equation, they're acknowledging it could be positive or negative. Let's look at our options. The only one there that matches is positive 30. That is B. So that is my answer. My little sort of shortcut right here when I get to this point, again, this is just how my weird little math brain works, is I know right now at this point that I'm going to have to take the square root in the next step, and I go, hey, 36 and 25 are both perfect squares. 36 is 6 times 6. 25 is 5 times 5. I could reorder that to be 6 times 5 times 6 times 5. Hey, look, that's going to be a perfect square. 6 times 5 is 30. If that made sense to you, then you probably have a weird little math brain like I do. And there's nothing wrong with thinking about problems in different ways. There's often more than one way to do a problem, but however you do it, you are still going to get B30 as your answer. Number 4, 3 more than 8 times the number x is equal to 83. Which equation represents this situation? Some people like to go to the answers first and then look at them one by one and see which one fits. I tend to prefer to just write my equation and then see where that equation is over here. So 3 more than something. Those are our first clue. 3 more than. 3 more than means I'm adding. So I'm adding 3 to something. I'm 3 more than something. What is that something? That something is 8 times a number x, or 8x. Okay, so now I have that first part. I have 3 more than 8 times a number x. Okay. And it says is equal to, so there's my cue to put in equals, is equal to 83. And I've written down everything they've given me. 3 more than 8 times the number x is equal to 83. Now I just need to look over here and see which of these matches it. First, 3 times 8, nope. 8x equals 83 plus 3. Now, here they're being a little tricky because you could move this over here and get 8x by itself, but it would not be plus 3. To do that, you'd have to subtract 3 from both sides, so it would be 8x equals 83 minus 3. They're being sneaky. They love doing that. Next one, 3x plus 8 equals 83. Nope, but finally, it took us a while to get there, but it is there eventually. Letter D, 8x plus 3 equals 83. That is our answer. A little note on these kind of problems up here, they just love these where you have to translate words into equations. This right here where they say is equal to is rare. Normally they just say is. A lot of times they'll say 3 more than 8 times the number x is 83. And anytime you're seeing is in that, that's sort of your key to put equals where there is. Just a little side note because, yeah, they love doing that. Number 5, Hannah deposited a fixed amount into her bank account each month. The function f of t equals 100 plus 25t gives the amount in dollars in Hannah's bank account after t monthly deposits. What is the best interpretation of 25 in this context? Before I look at the answers, I just want to look at this equation they're giving us. So it's 100, come on, there we go. 100, come on stylus, you want to work, you know you do. Plus 25t is the amount after t monthly deposits. So think about this in sort of real world terms if this isn't making sense when you just look at it. Again, for some people, they're going to look at it and immediately go, oh, I know what's going on, and that's great. But if you're having a problem visualizing it, I find sometimes using real numbers helps immensely. So let's say at 0 months, how much money does she have when she's just starting? 25 times 0 is 0, plus 100 is 100. So her first month, at the beginning of the first month, I say day 0. This is day 0. She hasn't done anything. She has $100 in her bank account. So we can say $100 would be her starting amount, right? That's what she started with. All right, and so what happens at the end of the first month? So t would be 1. What happens then? So if t is 1, 25 times 1 is 25 plus 100. So at the end of the first month, she has $125. What did she do? She added $25. So 1 month, she added $25. So we go, Okay, so 25 must be her monthly deposit amount. She deposited $25. So at the end of that first month, she has 125. And if you plug in 2 for T after 2 months, you're going to get that she had 150. So yes, she's putting in 25 a month. Okay, so that's what we've decided, that 100 is the starting point and 25 is her monthly deposit. So their question, what is the best interpretation of 25 in this context? Okay, with each monthly deposit, the amount in Hannah's bank account increased by $25. That sounds good. I think that's viable, but let's check the others just to be sure if there's not one that might be slightly more accurate. B, before Hannah made any monthly deposits, the amount in her bank account was $25. No, because we said before she made any deposits, it was 100. So that one is out. C, after one monthly deposit, the amount in Hannah's bank account was $25. Nope, that's not true. We just said it was $125. D, Hannah made a total of 25 monthly deposits. Who knows how many monthly deposits Hannah made? That's not what it is. We've already been told even that T is the monthly deposits, how many she made, which we don't know what it is. So D is out, and that confirms our answer that it is A. With each monthly deposit, the amount in Hannah's bank account increased by $25. Number 6, a customer spent $27 to purchase oranges at 3 per pound. How many pounds of oranges did the customer purchase? If you don't have to write this one down and you can just kind of visualize it in your head, awesome. If you have to write it down, that's fine too. Do what is best for you. So I'm going to show you the write it down sort of way that I would do it. Say, okay, so it's $3 per pound. So I have 1 pound of oranges, and that is $3. That's my ratio. 1 pound for every $3. So if I want to solve for how many pounds of oranges they purchased, so I don't know how many pounds, that's my X up here. As long as I'm doing pounds to dollars, if I can set up a ratio that's pounds to dollars, I'll be able to solve this. Okay, so unknown number of pounds, and they spent $27. And look at there, I am comparing apples to oranges, pounds to dollars on both sides. So now I can just look at the numbers. And then I can do it one of two ways. I can look at it as I'm converting this fraction and say 3 times what equals 27? Multiply by 9. So on the top, 1 times 9 is equal to 9. Come on. There we go. So that would tell me that is 9 pounds of oranges. Another way you can solve these kind of problems, especially if they don't have a straight like 3 times 9. In this case, it's very sort of like it's up converting, as it were. You can always cross multiply. That works also. You can always cross multiply. So 3 times x would be 3x. 1 times 27 is 27. Since 3 times x is 27, we need to do the opposite of that. Instead of multiplying by 3, we need to divide both sides by 3 to undo that multiplication. So on the left, I have just x now, and 27 divided by 3 is 9 pounds. Any way you do this, there's like 3 or 4 different ways I can think of, or how you want to look at it, you're always going to get that same answer. It is 9 pounds of oranges. Number 7, Nasir, I hope I'm saying that right, bought 9 storage bins that were each the same price. He used a coupon for $63 off the entire purchase. The cost for the entire purchase after using the coupon was $27. What was the original price in dollars for 1 storage bin? Okay, so I'm just going to write this out so you can see. So he buys 9 little bins. Boom. Why do I make it 3-dimensional? Why not? Okay, so he buys 9 storage bins. They're each the same price. And he has this total amount. And then he uses a coupon, so he gets $63 off. And then the cost is $27. So how can I find out what his original price was? I need to treat this like it's an X, and I need to undo what's been done. $63 was subtracted, which gave me $27, and I'm going to remove those dollar signs now so it's just nice and clean. So I'm going to add 63 because that's the opposite of subtracting, add it to both sides. And I learned that x is equal to 27. And I wrote minus, I'm so sorry, there we go. I was like, what on earth? 27 plus 63 is going to be 90. So his original purchase price was $90. And then he bought 9 bins. So this is equal to 9 bins. And I'm going to call my number of bins B. All right, so if 90, move my dollar sign again. We know we're talking about dollars, but it just makes it a little easier to look at. So if I know that 9 times B, the number of bins, there we go, is equal to 90. To undo that, to solve for B, B is being multiplied by 9, so I'm going to divide both sides by 9. On the right, I just have that B, and on the left, 90 divided by 9 is 10. So the original price for one storage bin was $10. And this is a write-in question, so you don't have to put that dollar sign, just put in 10, but we are talking about $10. Number 8. This one, their answers confound me. I'm not sure where they came from. We'll get to that in a second. We have a graph, and we are told for the linear function f, the table shows 3 values of x and their corresponding values of f of x. Which equation defines f of x? Anytime we have an f of x equation, and it can come in other ways. It can be g of x, h of x, whatever. F of x is the most common. It just is. So, okay, so we have f of x. When you have f of x equals something, every single time you see that, and honestly, when I first saw functions, I was just like, what's the point of this? Isn't this the same as y equals? Yeah, it kind of is. There is one key sort of difference, which with the f of x, it always sort of starts with the x. The x is the input, and the y is the output. The f of x is the output. That's the sort of difference. With y equals x, they are more like on a level playing field. They both can be input or output, depending how you look on it. But f of x is the input. So like if it was x plus 3, then it would be f of, let's say, 4 would mean I plug 4 in wherever there's an x, and then what I get is f of x. That's the output. After I do bloop, 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 I do the math, then the answer you get is your f of x value. Input and output. So we have this table where we have an input and an output. There is an equation where they plugged in 0 and they boop, 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 did the math and they got 29. Then they plugged in 1, they did the math, they got 32. They plugged in 2, they did the math, they got 35. Which of those equations was it? So we don't have to come up with this. We just have to look at the equations they've already provided and see which one would be true. The reason I find their answers so weird is so many of them get eliminated right off the bat. Like you can just, I don't know. I'll show you what I mean here instead of just beating around the bush. Let's start with our first value. X is 0 and f of x is 29. So I need to plug 0 in. I should get 29. If I plug 0 in for x in all of these, 3 times x, 29 times x, etc., I'm going to get 0, right? 3 times 0, 29 times 0, 35 times 0. All going to be 0. So what am I going to get? In this first one, if I plug that in, I'm going to get 29. That matches. That's a possibility. This one I'm going to get 32. So that one's out. This one I'm going to get 29. Okay, maybe. This one I'm going to get 35. That one is out. And then right off the bat, the next one, plug in a 1 and I get 32. You don't even have to do this math. Look at this down here. Look at this one C right here. Even before you do the math, if I plug in 1 for x, 35 times 1 is 35. I don't have to add 29 to it to know that's more than 32. Like 35 plus a positive number, is that 32? No. See, like you don't even, it's right there. That's it. If you want to go ahead and put those in, you absolutely can. You plug in 1 for x. 1 times 3 is 3, plus 29 is 32. Plug in 2 for x. 2 times 3 is 6, plus 29 is 35. You can if you want to. Honestly, when I looked at this, I thought there was a mistake. I thought just as soon as I saw these huge numbers for x and these tiny little outputs, and like I didn't even hardly do any math. I just looked on like 29 times 1 plus 32. Is that 32? What? 29 plus 32, 35 plus 29, 32 plus 35. I don't know what they were thinking, honestly, because I mean, it's nice. It's nice for us who are taking the test. I mean, why not give us one where it's really, I think, really straightforward. They don't give you any answers that are close. I'll say that. You don't have any with these small numbers. They all are just huge. I guess what they're counting on is you not knowing what f of x means and just plugging these numbers in somewhere and thinking that's going to give you the answer. But that's not the case for you, right? Right, because now you know what f of x means, and you will look at this and go, you silly College Board, why did you give me those answers? I know, without even doing any major math, there's no way I could do these things, plug 1 in and get 32 on any of these. How would that be possible to plug 1 in for x and get 32? Definitely A is my answer. Number 9. We have 2 triangles, and we are told the figures are not drawn to scale. Zoom in a bit more, because we're going to be writing on this one. Right triangles PQR and STU are similar, where P corresponds to S. If the measure of angle Q is 18 degrees, what is the measure of angle S? Okay, so similar shapes, in this case triangles, their corresponding angles will be congruent. Similar does not mean they look identical, as you can see right here. Even though it's not drawn to scale, they are not identical. That is true. They mean that one can be made smaller and it will line up on the other, or this one could be made bigger and it would line up perfectly. But again, the key sort of takeaway here is their corresponding angles are congruent. So because they are right triangles, we know these two, R and U, correspond to each other. But then we can't go by the picture because it says not drawn to scale, but they tell us P corresponds to S. Okay, so that means P is the same as S, and we know that because they're similar, then Q must also correspond to T and be congruent to T. So if the measure of angle Q is 18, that's 18 degrees, what is the measure of angle S? Well, I have a get this a little smaller. There we go. I have a right triangle here, so I know this one is 90. What would angle P be? And P and S are the same, so if I figure out what P is, I'll know what S is, and I'll have the answer to my question. Well, triangles, all triangles, the sum of their interior angles is 180 degrees. So I have angle P, then I have angle Q, which is 18, then I have angle R, which is 90, and together they're going to add up to 180. So 18 plus 90 is 108. So that angle P plus 108 is 180. Now to solve for P, I'm going to undo what's been done to it. Instead of adding 108, I'm going to do the opposite. I'm going to subtract 108, and I need to do that from both sides. So on the left, I have P, and on the right, 180 minus 108 is 72. So if P is 72, angle S is also 72 because it corresponds. So that measure of angle S is B, 72 degrees. Let's see, there's a little tricky one being 82. They're really counting on you just like accidentally typing something into your calculator or doing this quickly in your head and going, okay, 180, minus 90. Okay, so that's 90, then 90 minus 18, 82. They're counting on those careless errors, so be careful. That's always a good rule of thumb. Be careful in your calculations so that you can get all those points that you've earned and deserved. Number 10, the scatter plot shows the relationship between two variables x and y. Which of the following equations is the most appropriate linear model for the data shown? You don't really have to know that much about scatter plots to get this kind of problem, right? It basically is just saying a linear model is a line that comes closest to describing the trend that we see here. So I don't know where exactly that's going to be, but I know it's something like this. I'm drawing a line that approximately goes through the points. And the answers that they give us are going to be so wildly different that there won't be a question. This is just true of the SAT in general when they have these kind of problems. It's not going to be like, oh, what if I drew the line there and the line should have been there? No. It's not going to make that big of a difference. These are always going to be so wildly different. There's no question as to which one it is. The one sort of wrinkle that comes in this one is that while at first glance it may appear that they are in y equals mx plus b or slope-intercept format, not quite. They've put the x's last and those b's are first. So just be aware of that. Our slope, our x's are here. These are our y-intercepts. And what do we have? We have 2 that have a y-intercept of 0.9, 2 that have a y-intercept of 9.4. So just by determining where the y-intercept is approximately, we can eliminate half the answers. And then we also have, we have a positive and a negative slope, and then we have a positive and a negative slope here. And if you'll notice, they both, all 4 use 0.9 and 9.4. Okay, so let's look at where my y-intercept is. I've got it going through around 9. I have 2 options here that have 9.4. Like, okay, that could work. And 2 that are 0.9, which is down here. This is what I mean about the answer is, it's really obvious that I'm in the right ballpark. It's not like they're giving me a y-intercept of 9.4 and 9.2 and saying, which one do you think it is? That would require more calculation on our part, but they don't. They're saying, is it up in this area or is it down here? Like, okay, it's clearly up in this area. So my 0.9s are out. And now, I'm like, okay, well, how do I determine the slope of this? You don't have to. They both have the same slope. The only difference is one is positive and one is negative. So that's all I have to determine. This is what I mean when I say the answers are like, you don't have to do a lot of calculations. So I don't have to figure out what the exact slope would be for a line of best fit for this linear model. No, just is it positive or negative? Well, positive and negative slopes, think of them when you're, if you have a graph, if you are going left to right, if you are, like in English, if you're reading, you go left to right. And you think, someone is positive, they're upbuilding, they're like, things are going up, things are going good. Then it means it's going up. If you're going left to right, that has a positive slope. Think of somebody who's negative and they're just like, they're a downer. You're like, ugh, that person's so negative when I'm around them. I start feeling up here and I go, oh, I just get worse. I feel worse and worse the longer I'm around them. I'm sure you've met someone like that. So that is a negative slope. That's my little mental mnemonic, the way I figure it. I remember it because I read left to right and I think, okay, positive, I'm going up. Negative, I'm going down. You're like, oh, I just feel sad and negative. If you have a hard time remembering that, you can always plug in some real numbers. Like if I have, I've had a line that started at, or had the points 0, 0, and let's say it went up to 2, 2, and it's going through there. It's change in y over change in x. So change in y would be 2 minus 0. Actually, let's make this so it's more clear which ones I'm doing. Let's change that to a 3. Say 2 over 3. So the change in y would be 3 minus 0. The change in x would be 2 minus 0. The slope would be 3 halves. That's how you find the slope. You subtract the y's, you subtract the x's. And you can always do that if you have a hard time remembering which positive and negative are. But here, if we look at this line, it's clearly, no matter what its exact slope is, it is going down. This is a negative sloped line. So D is the only one that has that y-intercept in the 9s that also has a negative slope. D is my answer. 11, 2.5b plus 5r equals 80. The given equation describes the relationship between the number of birds, B, and the number of reptiles, R, that can be cared for at a pet care business on a given day. If the business cares for 16 reptiles on a given day, how many birds can it care for on this day? So this is a relationship showing, if they have more birds, they have to have fewer reptiles. If they have more reptiles, they can't handle as many birds. Because altogether, 80 is their maximum number in this equation. The value of 80 is showing how much they can handle. Okay, so 2.5b, let's plug in some numbers that were given. All right, we're told that B is for birds, R is for reptiles. That makes sense. Business cares for 16 reptiles on a given day. So I'm going to plug 16 in here for R. So 5 times 16 equals 80. And 5 times 16 actually is 80. So 2.5B plus 80 equals 80. Oh, look, they're maxed out. They're maxed out. You might stop at that point and go like, wait, okay, they can't handle any birds. Well, let's confirm that mathematically that yes, this is true. They cannot handle any birds. So let's solve for B. Since 80 is being added, let's subtract 80 from both sides. And I get that 2.5B equals 0. Yep, nothing for the birds. But let's follow it through to the end. 2.5 times B. Let's divide by 2.5 to undo that. 0 divided by 2.5 is 0. B is 0. They cannot handle any birds. They have all they can take with those 16 reptiles. A, 0 is my answer. 12. What is an equation of the graph shown? This is pretty similar to our sort of line of best fit that happened a couple problems ago. They're just asking you to identify the slope and the y-intercept of this line, or a good approximate, and see which of these matches it. This one's a little more precise, and the trick on this one where they're trying to mess with you is that it's not like my little graph here that's in the background where it's these perfect squares. They're drawing the squares as rectangles. You see over here in that graph? They're rectangles. So don't look at the shape of these. Look at the numbers. The numbers are telling the story. That's a little mean. It is. Okay, so I have 4 options here, and they are put all in y equals mx plus b format. So these numbers in front of the x, the m's, those are the slopes, and there, those b's are the y-intercepts. Now you notice they're all the same, -8. Okay, so you're like, oh, okay, I'm not being tested on finding the y-intercept because they've pinpointed it. They've shown it to us already that it's -8. So all I have to do is look at the slopes, and I have 4 different slopes here. My A slope is -2, my B slope is 1, my C slope is -1, and my Y slope is 2. Well, first off, we can get rid of 2 of them by just saying whether this is positive or negative. And as I mentioned in the previous one, my little mnemonic for it is I think of, because English is my mother tongue, so I read left to right. And I think reading left to right, that's how my eye travels. So if I'm starting over here and I'm around somebody that's positive, they're like, yay, they make me feel better. And like, yay, I start feeling better and things are going good. I'm moving up. And if someone's negative, I'm like, I start feeling down because they're so negative. And that's how my mood goes when I'm around positive or negative people. That's how I remember it. That's my mental trick. Use whatever works best for you. But the positive slopes are always going to be going up as they go left to right. Negative slopes always going down as they go left to right. And frankly, you don't have to do this. You don't have to eliminate some first. You can go straight to the graph and just figure out the slope and then look for it. Up to you. I'm just providing options. So looking at this slope, it is going down as we go left to right. So it is negative. So I know already that B and D are out, and I am just down to A and C. That is the kind of thing that's helpful. Let's say if you forget how to find the slope, but you may remember the positive negative, you can at least get it down to A and C and then take an educated guess. But let's look at some points here and see what is happening. And I have, Bling never likes when I do dots. Microsoft Whiteboard's always like, a dot? Did you draw a dot on me? Oh, how could you? All right, so it starts here. Let's see, this point is -8, 0, and it's rise over run. And we can do this as an equation, or we can just kind of count it out. So there's also a point there. So it goes to the right, 2. It's going towards that positive. So my run is a positive 2, and it's going down from 0 to -2. So that that rise is a -2. It's -2 over 2. That's going to be a -1. My slope is -1. You can also just put those points in instead of counting it on the graph. change in y over change in x. So it went from -8, 0 to -6, -2. So change in y would be 0 minus a -2. And you can start with either one. Just when you're doing this, make sure you start with the same pair and then go to the other pair. So I'm starting with this top pair and then, subtracting the bottom pair. So 0 minus a -2 on the top, and then -8 minus a -6 on the bottom. Give myself some room. 0 minus a -2 or plus a positive would be 2 on top, and -8 minus a negative or plus a positive, -2 on the bottom. Again, I get the same thing, -1. So C with that slope of -1 is my answer. Again, it's weird the way they've drawn the graph because they've drawn it flat to kind of trip you up, but they didn't do it very well. Because it doesn't make it look like it's a slope of -2. It makes it look like it's a slope of -1/2. -2 would be much more sharp, and that would be like if these boxes were rectangles like this. So I don't know what they were thinking, honestly. Like they were trying to we've laid a trap for you, but it's a really bad trap. Because if you just looked at the graph and were trying to judge it based on the looks, it would be -1/2, which isn't an option anywhere. There's no fractional exponents. Slopes. No fractional slopes. I don't know. I don't always understand what the College Board does. I'm just trying to help y'all beat them. All right, on to the next one. Number 13. If x over 8 equals 5, what is the value of 8 over x? Okay, there's two different ways that you can look at this. I'm going to show you both. First way is just to solve for x and then put it into that second equation. So if I have, whoa, that looks really thin. Let's bump that up so you can actually see what I'm writing. There we go. If x over 8 equals 5, what is x? Well, you always want to undo, make that heavier too, what's been done to x. So in this case, x has been divided by 8. So I'm going to multiply by 8 and do that to both sides. And I get on the left just x because those cancel out. And on the right, 5 times 8 is 40. And now that I know x is 40, what is the value of 8 divided by x? That would be 8 divided by 40. So you can simplify that, and that is 1/5, or you can just put it in your calculator and it's 0.2. Because this is one where you enter in your own answer, you can use either 0.2 or 1/5, 1 over 5 as the answer. The other way to look at this, and this is just sort of a little, what if I look at it this way kind of thing. That might be a little quicker, but not that way takes a whole long time. You can view this as a little ratio all on its own. So x is to 8 as 5 is to what? Well, it's 5 is to 1. You can always look at it that way. Any number that's just by itself is the same as itself over 1. So x, like if I was doing a proportion and I was trying to solve this, I go x is to 8 as 5 is to 1. So I could flip that upside down. I'd flip this upside down and it would still be true. So 8 is to x as 1 is to 5. And there's my answer again. Because they're wanting to know what 8x is, 8 over x is. It's 1/5 or 0.2. Again, that's just a little sort of, if you have that knowledge about ratios and you have that little kind of moment, it might save you a couple seconds. But honestly, there's absolutely nothing wrong with doing it the other way. It's not like that takes forever and a day. Either way is fine. Whatever makes the most sense to you and you're going to get the right answer and it's fast for you, that's the way you should do it. Number 14, 24x plus y equals 48. 6x plus y equals 72. The solution to the given system of equations is x and y. What is the value of y? Anytime you have a system of equations, you can solve it by substitution, by elimination, by graphing. I know a lot of students are going to go straight to the graphing. That's fine. Go for it. If you type these into Desmos, you're going to get 2 lines. Anytime you have 2 lines that are a system of equations, you're looking for where they cross. You're looking for that one point of intersection. Because there's only 3 options you get when you have 2 lines. They can either be parallel, in which there are no solutions. They can be crossing, in which case there's 1. or they can be on top of each other, in which case they are infinite. We are told there's one solution, so they're going to cross somewhere. So absolutely, you can plug that into Desmos and get your answer. Just make sure that you're looking for the y value, not the x. Don't make that careless error, because that's just painful. When you get back, you're like, what? I put it into there and yeah, we don't want that to happen. Okay, the other way you can do this is elimination. I would prefer that over substitution. I just think it works better here. And I'm going to show you this too. Even some people, sometimes when I do these problems and people are like, why didn't you just do it this way? Why didn't you use, graphing? That's so much easier. Maybe it is. Maybe in this particular problem it is. But I want you to have the knowledge to do substitution or elimination for those problems where it isn't, where the graphing takes longer. If you have all the tools in your tool belt or your toolbox at your disposal, then you can decide what's the fastest for any given problem, and you're not reliant on that calculator, which sometimes takes longer. Okay, so for this, I'm going to use elimination. Those y's are already lined up to cancel out. So I'm going to multiply everything on the bottom by a -1. So when you multiply all those by a -1, it just changes the sign of everything. So this becomes a -6x, a -y, and a -72. If I add all those together, 24x and -6x are 18x. The y's cancel out. And then 48 plus a -72 is a -24. So if I undo this 18 times x by dividing by 18, then I get that x is equal to -24 divided by 18, or we can simplify that to -4/3, because 6 goes into both of those. Okay, so now I know x is -4/3. I can plug it into either one of these, either one I want. I'm going to go for the 6x plus y equals 72. So if x is a -4/3, to do this quickly in my head without using a calculator, I go 6 times -4, then divide by 3. For me, that's just a little faster than typing 6 times parentheses -4 divided by a -3 parentheses equals. Your mileage may vary. So 6 times -4 is -24, divided by 3 is -8. So -8 plus y, why did I write plus, equals 72. So I have that -8. I want to undo that, so I'm going to add 8 to both sides, and I get that y is equal to 72 plus 8, or 80. So yeah, the only thing I can think about with Desmos for this that might make it a little more difficult is because your answer, that solution to that system of equations, is -4/3 and 80. If you are sort of zoomed in, as most times with Desmos it is, you're really going to have to zoom out to get to that point of -4/3 and 80. So it might make it a little harder to find. But yeah, it's going to be what's fastest, quickest, most accurate for you, and you are the best person to make that call. But those are the two ways that you can solve it. Number 15, line T in the xy plane has a slope of -1/3 and passes through the point 9, 10. Which equation defines line T? When we have a slope and we have a point, I love using the y equals mx plus b, or slope-intercept form. I think it works really quickly. They're telling us the slope. That's our m there. They're telling us the slope is -1/3, so I'm going to go ahead and replace that. I don't know the b. I do know one point, 9, 10. So I'm going to plug in that x and y into my x and y over here, and then I can solve for b. And if you look at my answers already, I'm already down to 2 because I've said the slope is -1/3. And this one, the slope is 13. Yep. This one, the slope is 9. C and D, they've written it a little differently, but if you see this -1/3 times x, if you combine those, if you did -1/3 times x over 1, which is how you would multiply those, then it is just -x over 3, which is what you see there. Okay, so I just need to solve for that b, and I'm going to, again, as I said, plug in x and y, 9 and 10. So let me do that. Plug in a 9 for x, and I got 10 there for my y. So on the left, I still have 10. Negative 1/3 times 9 is negative 3 plus b. So to get rid of that negative 3, I'm going to add 3 to both sides. And I get that b is equal to 13. And there we go. There's the answer that has 13 as that y-intercept. So D is my answer. Number 16. The function f of x equals 206 times 1.034 to the power of x models the value in dollars of a certain bank account by the end of each year from 1957 through 1972, where x is the number of years after 1957. Which of the following is the best interpretation of f of 5 is approximately equal to 243 in this context? Before I read their answers down here, because it's a lot of verbiage, I want to kind of establish in my mind first what I think it is. And then I'll see what matches. Some people like to start with the answers. Go for it if you prefer that. Absolutely. Okay, so I've got 206 f of x equals 206 times 1.034x. This is an interest. This is, compounding interest. So we have the $206. This number out in front is going to be the number that they started with, the number of dollars in the bank account at the beginning. So the beginning amount of it was $206. It's earning 3.4% interest. That's what this is. When you multiply 206 by 1.034, that 1 keeps the 206 there, because if I multiply 206 by 1, I get 206. But some more got added to it, and that's that 0.034. That's the additional interest. Because if I just multiplied by the interest, 0.034 or 3.4%, I would just get the amount that had been added to that 206. I wouldn't get the actual amount that's in the bank account, right? I would just get, oh, you earned this much money. Like when you get your bank statement, it would say, you earned this much in interest this year. That would be if I multiply by just 0.034. But when I multiply by 1.034, I get the opening account of the bank account plus that extra interest. And then to the power of x, they're telling us is x is the number of years. So 1 year after that beginning, it got multiplied by 1.034 and had extra money. Then 2 years, they multiplied it by this twice, because 2 years, it got that interest for 2 years, and so on and so on. So it's going to get more and more every year. So f of 5. 5 is going to be our x, and we're told that x is the number of years, right? And f of x, the output, is the value in dollars by the end of each year. So really, they're kind of already telling us we don't have to do that much figuring out in these problems. I just went through these little steps at the beginning. Why did you do that? I want you to have the skills not just for this problem, but any problem that's similar to it, because other times they may not explain to you that the f of x is the amount that's that you get at the end of the years. Just FYI, it's extra knowledge for you, bonus knowledge. So they're telling us here, x is the number of years. So f of 5, x is 5, would be 5 years. All right, so 5 years later. And then if I put 5 in for x, I just completely erased it. I should have erased x, but I'm just writing over it, being a rebel. And then you would get f of x, the output, which is the amount at the end of that year. Okay, so I'm going to do all that, and then I'm going to get an output. And they're saying f of 5 is equal to 243. So 243 is that output, the number of dollars. Okay, I'm looking at this. I've read it carefully. I've looked at my equation, and I feel very confident in saying that what this means is that 5 years after they opened the account, there was $243 in that account. And it opened in 1957, so 5 years later would be 1962. Okay, so I've looked at all their verbiage. They love their verbiage. And that's what I've got in my mind. It means that in 1962, at the end of that year, it was $243. Let's see which of these matches that. The value of the bank account is estimated to be $5 greater in 1962 than 1957. No, because we've said at the beginning it was 206. So A is out. B, the value of the bank account is estimated to be approximately $243 in 1962. Oh, that looks right. That looks right, but let's check the others just to be sure. C, the value in dollars of the bank account is estimated to be approximately 5 times greater in 1962 than in 1957. Wouldn't that be nice? That's a magic bank account. No, we were told that X is the number of years, not how many times greater. And we can see it's not 5 times greater. C is out. D, the value of the bank account is estimated to increase by approximately $243 every 5 years between 1957 and 1972. No, it did not increase by $243. It increased by $37. Yep, so $37. D is out. Confirms it. B is our answer. Okay, number 17. For a certain rectangular region, the ratio of its length to its width is 35 to 10. Okay, so I've got this rectangular region, and its length to its width is, the ratio is 35 to 10. That's not the actual numbers of it, but it could be. But the ratio is 35 to 10. So if the width of the rectangular region increases by 7 units, how must the length change to increase this ratio? There's a couple different ways you can look at it. I'm going to show you the sort of mathematical ways that will work for every single problem. And then we're going to go over here and look at ways you could solve this particular problem just by looking at the answers. I don't want to start with that because there's no guarantee if you get a similar problem on the SAT that they're going to be as nice as they are with the answers here. Because honestly, I think you can get this right without doing any math. But let's show you the math because you need to know the math. All right, so I am just going to use these actual numbers, 10 and 35, for my first go at this, my first method that I'm showing you. Because it works. The ratio is 35 to 10. So it could be actually 35 inches by 10 inches or 35 feet by 10 feet. So the width is increased by 7. Okay, so the width increased by 7. Now I want to keep that same ratio. How much got added to the 35? Okay, so I'm going to set up a ratio. It started, the width was 10 and the length was 35. And then 10 plus 7 on the top, the width went up to 17. And the bottom went up by some unknown amount. And I can solve it just as it is. And I can solve for x. And so I can cross multiply. I can do it like this. 35 times 17. That is 595. And when I'm cross multiplying these, I'm distributing. 10 times 35 is 350, and 10 times x is 10x. So I'm going to subtract 350 from both sides to get rid of it. So I'll only have that 10x over there on the right. And when I do that, I get 245 on the left and 10x on the right. I'm going to divide by 10 on both sides to get rid of that 10 times x. I'm undoing it. And I get that x is equal to 24.5. So that was the increase. It had to increase by 24.5, and that is B. So there's my answer right there. So that's one way you can do it, by using this ratio and using like a real world scenario. Another way that you can look at it, and this may make more sense, the reason I'm showing you multiple ways is I want you to have multiple tools at your disposal and say what makes the most sense and what's the fastest, and that's what you're going to do. Okay, another way you can look at it is just look at the ratio. Okay, so it's 35 to 10, or I would even simplify that just to make it really sort of simple. And I'm going to, not in the strict sort of how we simplify fractions way, but just so it's more of like a quick ratio, like 5 to 1, 6 to 1. If I divide them both by 10, I would get 3.5 to 1. Okay, so this is a ratio of 3.5 to 1. If the width is increased by 7, so that width, the increase. Now I'm just thinking about not the actual full length, but the increase. I'm isolating the increase. So it was increased by 7. How do I get from 1 to 7? I multiply by 7 because we're talking about fractions here. If we're scaling them up, scaling down, we have to be multiplying, not adding. Okay, so then on top, to get the same, like how much was that increase, I have to do the same thing. 3.5 times 7, and that gives me 24.5. Same answer. That's another way to look at it. This way, while it's quicker, sometimes that can be a bit confusing because we're talking about, wait, are you saying that the length increases, that the new length is 24.5, the amount of the increase? Again, we want what makes the most sense to you. What's clearest to you, that's the method you should use. Right, and last but certainly not least, for this particular problem, I don't think you even need to do any math. You can just look at the answers. Okay, and we'll just think this through logically. So there's a ratio 35 to 10. So we know the length is longer, right? If it's 35 to the length to 10 of the width, we know the length is longer. And with ratios, you know, when things stay proportional, they go up. Like say if this was 2 to 1 and we went up, the bottom went up to 2, we'd multiply by 2. What will we need to do the top? Multiply by 2. It's that principle. You know, we're changing fractions here. Ratios are fractions. We're changing fractions, we're multiplying. We're never adding to keep those fractions the same. They have to be multiplying to keep the fraction the same. And that's what they're saying. We have to maintain the ratio. We have to keep that fraction the same. Okay, well, the bottom goes up by 7. The width increases, goes up by 7. So is the top going to increase or decrease? Well, to keep the same proportion, it's going to do the same, right? If this one goes up, that one also has to go up. The bottom one goes down, the other also goes down to keep that same proportion. So already, the two that say decrease are out. I've already eliminated halfway. And then if you have that knowledge that ratios are like fractions, and when we're increasing fractions, we're scaling up, we're always multiplying, never adding. This one says increase by 7 units. That's adding, because this one added 7 units, and it's saying, oh, to keep it the same, you have to add 7 on the top. No, it's a proportion. So if it increased by 7, you have to figure out how much it was multiplied by, and then multiply the top by the same thing. So even without doing the math, and without figuring that out precisely that it is 24.5, just the fact that our only options are 7 and 24.5, if you have that knowledge of how ratios work, you'd know it would have to be more than 7. It's going to be B. That's sort of like the logic way of doing it. So there's 3 different methods for you. I always say learn as many things, as many ways to do a problem as you can, because you don't know what kind of problem you're going to get on the final test. But hopefully I didn't cause too much confusion by giving you the multiple ways to solve that. 18. Square P has a side length of X inches. Anytime they tell me something geometric and, you know, they don't draw it, I always draw it immediately. So this is square P has a side length of X inches. Square Q has a perimeter that's 176 inches greater. Okay, I'm not drawing to scale. I've got Q. Okay, and its perimeter is 176 inches greater. So I'm going to write this as, I'm going to say the perimeter of Q is equal to the perimeter of P plus 176 inches. Okay. The function f gives the area of square Q in square inches. Which of the following defines f? All right, well, first let's figure out what the sides of Q are, because we need those sides to figure out the area, because it's going to be the side times the side to give us the area. Well, if the perimeter of P is X, the side of P is X, what would its perimeter be? Each side is X. Perimeter is adding up those sides, or like how much fence would it take to go around the square. There's 4 x's, x plus x plus x plus x. The perimeter of P is 4x. So I'm going to go down here and I'm going to write that. Right down here, it is 4x. So the perimeter of Q is 4x plus 176. Now it's a square. So I know there's 4 x's and then there's that 176 extra. So okay, so I've got my 4 x's one on each side. That takes care of that. Now, how do I divide up that 176? It's a square, so all the sides are equal. So I'm going to divide it by 4, and then I'll know how much to add to each side. So 176 divided by 4 is 44. So I know that each side is 44 longer than the side, I'm running out of room here, of square P. Because if I had 44 plus 44 plus 44 plus 40, whoop, 44, I'm going to get 176. So that's where that 176 comes in. That's where that P up there was helpful. Well, now at this point, we don't need the P anymore. All we need is this, and we have now the side of Q. It's x plus 44. So if one side is x plus 44, and I want to find the area, I need to multiply those two sides together. So that would be x plus 44 times x plus 44, or x plus 44 squared. And that is A. That's my answer. Number 19. The given equation relates the distinct positive real numbers w, x, and y. Which equation correctly expresses w in terms of x and y? Anytime you have, like this could be also said as solve for w. In this case, they're being a little nice and saying expresses w. Anytime you see that where you have a ton of variables and only one equation, and it says to solve for x, solve for w, solve for y, you can't get an actual number. You can't say, well, w equals 5. Impossible. What they're wanting is whichever variable they told you that was solve for x, solve for w, solve for g, whatever. They want that variable by itself, whatever it may be, and everything else in the equation over on the other side. Just that's it. Get everything else over, isolate that one variable. All right, so we're starting with 14x over 7y equals 2 times the square root of w plus 19. Always start on the side that has the variable you're wanting to end with. In this case, we want to express express w in terms of x and y. So we're going to start over here. We're going to start getting rid of things, undoing what's been done to w. So first, it's being multiplied by 2, so we're going to do the opposite of that. We're going to divide by 2. But because I have a fraction over here, I'm going to tweak it a little bit. I'm going to say, instead of divide by 2, I'm going to say multiply by 1/2, because those are the same thing. And that makes it a little more easy, a little easier to combine those over on the left. So again, divide by 2, multiply by 1/2, same thing. When you're dealing with fractions, the 1/2's easier. Okay, so on the right-hand side, that 1/2 and the 2, those cancel out. On the left, 1 times 14x is just 14x, and on the bottom, 2 times 7y is 14y, because I can multiply that 2 by 7. And on the right, I have the square root of w plus 19. Well, before I go any further, look over here. I've got a 14 times x and a 14 times y. When things are being multiplied, not added or subtracted, but multiplied in fractions, you can cancel out things that have factors in common. So like if this had been 7, I could have said, oh, 7 goes into 7 one time and it goes into 14 two times. I can simplify it like that. Absolutely. But here it's even easier. 14 and 14 on top. So 14 goes into 14 one time, 14 goes into 14 one time. So it's just 1 and 1, and essentially I am left with, there you go, just x and y. Not essentially, I am. X and y is what I am left with. So x over y equals the square root of w plus 19. To get rid of that square root, I need to square this whole thing. So I need to square both sides. So on the left, I have x over y squared. Let me zoom out a little bit. Running out of room as usual because they're right too big. So x over y squared equals w plus 19. And I am going to undo that plus 19 by subtracting 19 from both sides. And now my w is by itself. And what do I have? I'm going to write it over here a little bit. I have that x over y squared minus 19, and that is w. And let's look over at our options, and looky there, there it is. C, w equals x over y, all in parentheses, squared, minus 19. C is my answer. Number 20, point O is the center of a circle. All right, so right off the bat, I'm going to draw a circle, and there's point O. The measure of arc RS on the circle is 100 degrees. Okay, so if I start here for R, whoa, it hates me writing points. How dare you write a point? Just can't take it. Points. Right, so if R is there and the arc on this circle is 100 degrees, arcs can be measured in degrees. I know some people have a real problem with this. I've gotten some comments with people telling me, you're so wrong, Mark. Arcs can't be measured in degrees. They can. I'm sorry. I'm not sure why it's such a thing, but it is. I've had this multiple times. Arcs can be measured in degrees. It's telling you what proportion, what portion of the circle it is. So a whole way around is 360 degrees. So it's 100 of those 360 degrees. It's more of a proportion than it is. Just like with an angle, we're saying, you know, if we're starting here, we're going like, what proportion of 360 degrees is it? It's the exact same thing. It's not saying how long it is. It's saying what portion of the circle. So, and it's going to look like if you drew a 100-degree angle, more on this in a second, that arc is going to be like where that 100-degree angle hit the circle. So my point S is probably around here somewhere. That's point S. And this would give me this arc RS that is 100 degrees. Now it's saying, what is the measure in degrees of its associated angle ROS? Now, going by what I just said, where it's like if you had a 100-degree angle, and where it would hit would be that 100-degree arc, you're probably guessing that this is 100 degrees, and you're right, it is. The rule for this is it's called a central angle, an angle that has its vertex in the center or on the center of the circle, on that center point. The arc that it intercepts, the intercepted arc, the arc that it's eating, is going to be the same degree measure. Always. Always, always, always. The other one, which I've seen sometimes on the SAT, is if you have an inscribed angle. If it was like this, if this was our scenario, and this was 100 degrees, when the point of the angle is on the circle, not in the center, that's called an inscribed angle. It is half the arc. So in this case there, it would be 50 degrees. Always. And it doesn't, it's maybe hard to kind of comprehend. You kind of have to play around with it to see it. So like if I had these 2 points, it doesn't matter if the angle is there or the angle is there or the angle is there. It's always going to be 50. It's kind of hard to wrap your brain around without actually seeing it in action, but it is. Those are 2 very common theorems, inscribed angles and central angles, that come up on the SAT. Again, this one is a central angle. It will always match. Since the arc is 100, the central angle is also 100. 100 is my answer. Boom. Number 21. The expression 6 times the 5th root of 3 to the 5th times x to the 45th times the 8th root of 2 to the 8th x times x is equivalent to a times x to the power of b, where a and b are positive constants and x is greater than 1. What is the value of a plus b? And if your eyes glazed over and like, how? I get it. I get it. This is one, I don't know, this this module has some doozies. I think it lures you into a false sense of security because earlier problems, I think, are a little more straightforward. And then here at the end, it just starts slapping you in the face. This one, you need knowledge of exponents to solve easily and quickly here, and exponent rules. Okay, so here's our little base concepts that are going to apply. If I have 5 squared times 5 cubed, if I'm multiplying those together, I keep the same base, I add the exponents. Because this would be 5 times 5 times 5 times 5 times 5, 5 times itself 2 times, 5 times itself 3 times, all together is 5 times itself 5 times. Right, so multiplying, same base, add the exponents. That's our first principle. Another one is that we can change roots to exponents. So 6 to the power of 1/2 is the second root of 6 to the power of 1, or the square root of 6. It doesn't matter what these numbers are, this same pattern applies, and you can go back and forth. So if I had 7 to the power of 3 eighths. That bottom number becomes the root, and the top number becomes the power inside. Again, you can go back and forth. This is going to come into play. And last but not least is if you have the root of something and there's a variable underneath with a power, like say this was the 7th root of x to the power of 10, you can divide 7 into 10. However many times it goes in is what you can pull out. The remainder is what you leave behind. So in this case, 7 goes into 10 one time. So 1x, or x to the power of 1, comes out. The remainder is 3. X cubed is what's left behind. The reason for this is because x to the power of 10 is the same as, x times itself 10 times. So we could say that is x to the power of 7 times x to the power of 3. Because remember, 7 plus 3 is 10, so you can go back and forth by that rule we just said. So the 7th root of x to the 7th is 1. Like the square root of x squared is x. The cube root of x cubed is x. Just how it works. And that x cubed is left behind. So let's try another one. Like if we said this was x to the power of 35, 7 goes into 35 5 times. So x to the 5th comes out and nothing is left behind. There's no remainder, so nothing is left under the square root. Okay, so all of those principles are all coming together into this problem. Okay, so we have 6 times, oh, and also I should say, if you have square root of 2x, you can split that up to square root of 2 times the square root of x. Yes, that's the other one we can do. So it's really testing that we know all of these and that we're creative in our math, that we can solve this. Okay, so I have 6, and I'm going to start splitting things up, times the 5th root of 3 to the power of 5 times the 5th root of x to the power of 45. Then I have the 8th root of 2 to the power of 8, and I can split these up, so I'm gonna. And then we have the 8th root of x. Okay, I can simplify some of these right off the bat. It's not as crazy as it looked. First, I have the 5th root of 3 to the 5th. That's just 3. Bring my 6 down. The 5th root of x to the 45. Remember, it's how many times does 5 go into 45? And then that comes out, remainder's left behind. 5 goes into 45 9 times, no remainder. So x to the power of 9. Then the 8th root of 2 to the 8th is just 2. The 8th root of x, I'm going to use that property of exponents where I can convert it into an exponent from a root. So this is the 8th root of x to the power of 1. So that's x to the power of 1/8. All right, now that's much, much easier to deal with. I can multiply my plain numbers. 6 times 3 is 18. 18 times 2 is 36. And these have the same base, so I can add those exponents. 9 plus 1/8 is x to the power of 9 1/8. Or we can say that is the same as 73/8. Okay, I'm changing that. I'll tell you why in a second why I'm doing that. Actually, let's just leave it as it was before, 9 1/8. We'll change it in a second. Okay, so let's go back up to the top. It says this was equivalent to a times x to the power of b. Well, I've got that. I've got my a times x to the power of b, so I know what my a's and my b's are. So my a is going to be 36, and my b is going to be 9 1/8, or 73/8. Either way, it's fine. We're going to have to do some conversion at some point, or division in a calculator. It doesn't really matter, just before the end. It doesn't matter when we do it, I should say. And our final question is, what is the value of a plus b? So we need to add these together. We need to add 36 and 9 1/8. When we add those together, we get 45 and 1/8. But because this is a problem where we have to input the solution, we cannot enter it like this. You are not allowed to enter a solution like that because it looks like 451/8. You'll get it wrong. Don't do it. You either have to convert it to a decimal, or you have to put it in an improper fraction form. So if I put this in an improper fraction form, I would do 8 times 45. 8 times 45 is 360. And then we add 1, and that becomes 361 eighths. Because that's not an awkward. I couldn't even say the word awkward. That's not an awkward fraction at all. So you can enter it that way as 361 eighths, or you can enter its decimal equivalent. Both are acceptable, but that is the answer. As weird as it looks. Number 22. A right triangle has sides of length 2 square root of 2, 6 square root of 2, and square root of 80 units. Okay. This, I think the only sort of trip up that might be here is not being sure which leg of the triangle is which. That can happen. So if you're not sure which of these is the hypotenuse, plug them into your calculator and see which one is the longest. 2 square root of 2, 6 square root of 2, square root of 80. You know, I don't expect anyone to know just off the top of their head, well, yes, of course, this would be the longest. I don't expect that. We're going to jump ahead and assume you've done this in your calculator and you've realized that the square root of 80 is the hypotenuse. So that's going to be out here. And then our two legs, I have not drawn this to scale, are 2 square root of 2 and 6 square root of 2. And it is a right triangle. Because it's a right triangle, we know that, you know, I can do 1/2 base times height, and the two legs are the base and the height. Always. So that makes things nice and easier. So area of a triangle is 1/2 length of the base times the length of the height. So 1/2 times 2 times the square root of 2 times 6 times square root of 2. Yes, I'm splitting them up just to make it a little easier to see how this all goes down when we multiply. Square root of 2 times square root of 2 is just 2. And then I go, wait a minute, 1/2 times 2 is 1. So the 1/2, the square root of 2, and the square root of 2 all cancel out. And I'm left with 2 times 6, or 12, and that is B. That's my answer. The biggest difficulty in this one is just making sure you have the legs identified. That it is that 2 square root of 2 and 6 square root of 2 are the legs, and square root of 80 is the hypotenuse. Another way to do this, if you didn't want to plug all those into your calculator, is you can square each of them, and that will get rid of the square roots, and then you can see which one's the longest as well. If you did it that way, 2 square root of 2 squared is you square this one, you square this one, you multiply it together. 2 squared is 4, square root of 2 squared is 2, 4 times 2 is 8. Then you have 6 square root of 2. 6 squared is 36, square root of 2 squared is 2, 36 times 2 is 72. And then finally, square root of 80 squared is 80. So that one's the longest. And yes, Pythagorean theorem works. 8 plus 72 is 80. A squared plus B squared equals C squared. Again, that's how you do it manually, not using your calculator, confirming that square root of 80 is the hypotenuse. But again, once you have that, that's the hardest part, is making sure you have the legs correct, and then it's just 1/2 base times height, which you can do manually or in your calculator, and will get you 12. And that's your answer, B, 12. Number 23. The expression 4x squared plus bx minus 45, where b is a constant, can be rewritten as hx plus k times x plus j, where h, k, and j are integer constants. Which of the following must, that's going to be the key here, must be an integer? Not could be, not might be, has to be. Okay, this is a conceptual one. This section seems to have quite a few of those. But let's think about, we have to think about FOIL. We have to think about that multiplying binomials, how that works, and what is the result when we do that. Okay, so 4x squared plus bx minus 45. And it can be factored. This can be factored, and yeah, let's make it colorful. So it can be factored as hx plus k times, I'm rethinking this. It can be factored as hx plus k excuse me, times x plus j. Okay, now when I first looked at this, I thought I had to try to figure out what h, k, and j are, what exactly they are. It kind of, I mean, one of them you can figure out, h you can figure out, but the rest you can't. We're told that h, k, and j are integers. They are like 1, 5, -7, 10. No fractions, no decimals. They are integers. So that's helpful. Now think about FOIL, like how FOIL works. I promise we'll get over here to that in a minute. What happens to get from those binomials up to this? We would multiply the first, we would multiply the outside, the inside, and then the last. So let's do that. Let's multiply these out and see what happens. Well, hx times x would be hx squared. Then I would have my outside, which would be hx times j. So j times hx. Then I would have inside k times x. And then finally I would have k times j. Now, if we compare these, compare what we got here to what we have here, you'll notice a couple of things. Well, one, we know that h has to be 4, right? It's the number in front of the x squared. It has to be 4. So I'm going to write that over here. H equals 4. And I'm going to go ahead and replace it. There we go. 4 times j times x plus k times x plus k times j. The next one is this last one, k times j. There's no x. That must be -45. And I know they're both integers, right? So I know k times j equals -45. All right, so I can kind of assume that there's going to be some combination here, and the negative could be on either one, that k could be 1, j could be 45, and either of those, one of them has to be negative to get that negative, that k is 45 and j is 1. The only two other options are 5 and 9 or 9 and 5. So those are my integers that multiply, or actually no, sorry, and 3 and 15 and 15 and 3. Okay, there we go. So those are my integers, almost forgot one, that multiply to 45. And again, that negative can be anywhere, just as long as one of those is a negative. Okay, so I kind of have some ideas as to what this would be. And so I know that, you know, I'm going to replace that over here. Random ruler. That k times j is the same as -45. All right. Now that I kind of have all these, you know, this functionality, and that, you know, 4j plus k equals b. I know that as well, because 4jx plus kx equals bx. So 4j plus k equals b. I also know that. All right. So let's look at our options. Which of the following must be an integer? B divided by h. You go b divided by h. The only way that this must be an integer is if b were equal to 4 times an integer. No, we have no way of knowing that. We know that b is equal to 4j plus k. How do I know that that's divisible by 4? I don't. In fact, it's pretty unlikely that it's divisible by 4, looking at what j and k could be over here. You know, if I plugged this in, like if I plugged in 15 or a -15 in for j and a 3 in for k, I'm getting an odd number when I do that. So already I can tell just with one example, this must not be true. A is out. B divided by k. Same kind of thing. B is k is added to a number to get to b. It's not being multiplied. K would have to be multiplied by something to get to b in order for it to always be an integer. That's what we're looking for. These two things are being, because all of these are being divided. So we want to have the opposite be true, that two numbers are getting multiplied together to form this number. So previous one, it was like, what's being multiplied together to get the h? Well, h is not getting multiplied by anything. That was A. And then B, we have B divided by K. K is getting added into something to form B. These two are getting added together to make B. But they're not getting multiplied by anything to make B. Like, okay. So as you probably guessed, here, K times J equaling negative 45. Look at our C and D. 45 divided by H or 45 divided by K must be an integer. First, 45 divided by H. Well, we know H is 4. So we can eliminate this one without even doing any hypotheticals, because we know 45 divided by 4 is not an integer. We don't even have to think about the logic of why it must be true. This only leaves D. This one better be right. Hopefully our logic has worked. And let's say 45 divided by K must be an integer. Yes, absolutely. Because K times J, and K and J are both integers, we're told that up here, equals a negative 45. Negative 45 and positive 45, again, we're just putting a negative somewhere. But those same core numbers are going to be involved. So yes, if I divide 45 by K, or in this case I know negative, but here 45 divided by K, J is going to be one of these numbers, depending on which of those numbers K is. So it's going to be an integer. It has to be, because K times J is that. And you can adapt this and say, all right, to get to 45 divided by K, boom, because I divide, we could say like a negative J, because I'm dividing both sides by K, and I get to that, and if I could divide by a negative K on both sides, then I could end up with negative J equals 45 over K. That's your algebra version of it. But again, we know J is an integer, so negative J is also an integer. I'm sorry if this one wasn't as clear as some of my other explanations. Because it is so sort of conceptual, it is not anything you're going to find in your math book. I really hope that made sense. If you have any questions, please post them down below. But yeah, it really is just this sort of conceptual idea, thinking about how FOIL works. Yeah, they're just testing your creativity, I guess, with the math, and not really a single math concept. Number 24, y equals 2x squared minus 21x plus 64, y equals 3x plus a. In the given system of equations, a is a constant. The graphs of the equations in the given system intersect at exactly one point, xy in the xy plane. What is the value of x? This problem, man. If you read their directions, the College Board's instructions for how to solve this problem, you might have felt your brain exploding just a little bit, and I wouldn't blame you. I'm going to go through right now their explanation for how to do this problem. And then I'm going to show you the way I would do it. My way takes about 10 seconds. I wish I was exaggerating. Maybe 30 at the most. Their way, geez Louise. All right. According to the College Board, this is how you solve it. You have a given system of equations. There is a single solution. So to solve for it, they're going to use first substitution. Y equals 3x plus a. They're going to plug it into this one. They phrased it as subtract y from both sides. I don't know why they phrased it that way. I think that's so dumb. So I'm phrasing it a better way to make their explanation make more sense. Yes, I'm casting shade. I'm a little mad at them about this problem. Yeah, I'm throwing shade at them. Okay, so plugging 3x plus a in there, you get 3x plus a equals 2x squared minus 21x plus 64. Come here, 64. Now I'm going to put everything over here so it's equal to 0, and then I can do some more fun stuff with it. So I'm going to subtract 3x from both sides. And that gives me a is equal to 2x squared minus 24x plus 64. Keep writing the 4 first. You'd think there we go, 64. Then I'm going to subtract a from both sides because we like our quadratics to be equal to 0. So 0 is equal to 2x squared minus 24x plus 64 minus a. And we're told a is a constant, so these kind of go together. Now, and they are together my c. And when I say my c, we're talking about ax squared plus bx plus c. So this would be my a, negative 24 would be my b, and 64 minus a altogether would be my c. Now we're told this has one solution. One. Okay, so we've combined them together. We've made this little hybrid equation, and it has one solution. There is something called the discriminant. And it's that same little, if this is a, this is b, and all this is c. In the quadratic formula, is negative b plus or minus the square root of b squared minus 4ac all over 2a. This bit underneath the radical is the discriminant. It tells you how many solutions the quadratic has. If that is equal to a positive number, so you're getting a square root of a positive number, you're going to get two solutions. It's like if it was 2, you have negative b plus 2, negative b minus 2, two solutions. If under the discriminant it is equal to 0, there is only one solution because plus and minus 0 would be the same thing. If it is a negative number, then there are no real solutions because we can't have a negative square root as a real number. So b squared minus 4ac is the discriminant. Okay, so now they're saying I want to put this in here, b squared minus 4ac is equal to 0, and then solve for it. Okay, so b squared minus 4 times a times c, it has to equal 0 for there to be only one solution. My b is negative 24, so negative 24 squared minus, parentheses, 4 times my a is 2. Getting ahead of myself. And my c is 64 minus a. So I'm going to put all of these in parentheses. And that's all equal to 0. Okay, now it's time to get out our calculators. Because I know a lot of things, but I don't know 24 times 24 off the top of my head. That is 576. And 4 times 2 is 8. And then 8 times 64 minus a. I need to distribute that. And again, let me get rid of those. It's not so confusing. This is all going to be equal to 0. So 8 times 64 is 512. So I'm putting all of this in here. So it's 576 minus, I'm putting all in parentheses, 8 times 64 is 512. And then 8 times negative a is negative 8a. And then because it's minus all of this, I'm going to change this plus to a minus and that to a plus. See, I think this is so easy to mess up at this point with all those minuses, and I just think it's more trouble than it's worth. I digress. 576 plus a negative 512 is going to be, what was it again, 64? And then we just have that 8a. Okay, so now 64 plus 8a is equal to 0. I'm going to take so much room on this one. So next I'm going to subtract 64 from both sides, and I get 8a is equal to negative 64. Divide both sides by 8. Oh, I'm just running out of so much room. And I just know that the font and the text here is going to get so tiny. And then a is equal to negative 8. And like, wait a minute, I'm trying to solve for x and y. How does negative 8 help me? Okay, next step the College Board wants you to do, I am putting all the blame for this on them, is they want you to put that into this equation up here. You with me? So 0 equals 2x squared minus 24x plus 64. Keep doing that, writing that 4. 64 minus a, so minus a negative 8. Or 0 is equal to 2x squared minus 24x plus 64 minus negative 8 is 72, because that's minus a negative is plus a positive. Okay, so to factor this, I can divide everything by 2 first, to kind of simplify it a little bit. and I get 0 equals x squared minus 12x plus 36. What multiplies to a positive 36 but adds to a negative 12? If you know your patterns really well, you may already see this, but that is going to be negative 6 and negative 6. This is a perfect square. So 0 is equal to x minus 6 squared. So you can take the square root of both sides, and that gives you 0 is equal to x minus 6. So x is equal to 6. And there's my answer. That is C, 6. Okay. That's so much effort. And I mean, I'm not against math problems that take effort. They're fine. But the SAT, where every second counts, and they throw this in there, and this is their explanation that they give. So, okay, we're going to try another way. Let's go over to Desmos. Okay, so now we're in Desmos, and I've entered that first equation, y equals 2x squared minus 21x plus 64. And now, if you remember, the second equation is y equals 3x plus a. Now, I don't know what a is, so I can't put that in there. But just look at this graph. See what's happening here? As soon as we have that 3 in front of the x, because y equals 3x, we know that's a line. It just has an x and a y, no squares, it's a line. That 3x gives it a slope of 3. Now, normally, when we think of a line intersecting a parabola at one point, we think of a horizontal line going through the vertex. That's the most common when you see a line crosses a parabola at one point, especially in algebra. We're not talking calculus or anything. You're going to be talking about through the vertex. That's not the case here. So what could this be? The only way it could be is if it's intersecting somewhere on this side, like this line is moving over to the right or moving down, and then it's hitting just one little point over there. So when I thought about this for a second, I go, I could start doing all that crazy math. Or I'm assuming that the y-intercept, that a, is most likely a whole number or it's an integer. So I'm going to start putting in numbers. I know it needs to go down. What if I did -1? Okay, down, but not enough. So I just very quickly started going backspace, new number, backspace, new number. 2, 3, 4, 5, 6. We're getting close. 7, 8. Hey, I only see one dot there at their point of intersection. And that is, it was highlighted a second ago. There we go. It is 6 and 10. What is my x value there? 6. And there's my answer. So this is something where sometimes if we take the time to think, is there another way to solve a problem? You can find a much faster solution. I'm not saying Desmos is the savior, is going to be your savior on all these type problems, but my goodness, can it cut out some of the work sometimes. And this is a prime example of that. Now, we couldn't just plug it in and get the answer. And I think a lot of students are used to that with Desmos. You just plug it in and boom, there's our answer. This one, you do have to get a little creative to use Desmos. You have to kind of think of like, oh, let's try some numbers here. Which way do I need the line to go to make this happen? But if you can, if that eureka moment hits, this is a great way to save yourself a ton of time on these puzzle problems, using Desmos to help you get around that mess of math that we just saw. Number 25. An isosceles right triangle has a hypotenuse of length 58 inches. What is the perimeter in inches of this triangle? Okay, a couple different ways you can do it. An isosceles right triangle is a right triangle with the isosceles, so it has two legs that are the same. And we're told the hypotenuse is 58. So you can solve this using the pattern that is for an isosceles or or 45, 45, 90 right triangle, which is that this side is A and this side is A. This is A times the square root of 2. You can use that pattern over here. So if you want to find the legs of the right triangle, you can say, since this is A times the square root of 2, to find A, I need to divide both sides by the square root of 2. So that would be a is equal to 58 times the square root of 2. And you need to simplify that. You need to get rid of the radical in the denominator. So you multiply by that radical over itself, because that's the same as the number 1. Any number over itself besides 0 is equal to 1. So I can multiply this by it and it won't change anything. But it will get rid of that radical in the denominator. So it will be 58 square root of 2 over square root of 2 times square root of 2 is 2. And then we can simplify it even further, because 2 goes into both of those. It goes into 2 one time, and it goes into 58 29 times. So it is equal to 29 square root of 2. That's my A. So up here, fill that in, 29 square root of 2 and 29 square root of 2. And now I need to add those up since we were talking about perimeter. So that is 29 square root of 2 plus 29 square root of 2 plus 58. 29 square root of 2. When you have radicals like that, you can treat them like variables. So 29 square roots of 2 plus 29 square roots of 2 is 58 square roots of 2 plus 58. And that's it. It's 58 plus 58 square root of 2, which is C. If you don't remember this formula, you can still get the answer. You know, as we always say, a lot of times there's more than one way to skin a math problem, to paraphrase an old and horrible expression, which I'm not sure why I ever became an expression in the first place, but the Pythagorean theorem says a squared plus b squared equals c squared. Now here we know both of these sides are the same, so I could say a squared plus a squared equals my 58 squared. So my 58 squared is 3,364. A squared plus a squared is 2a squared. And then I would divide by 2 and I would get a squared is equal to 1,682. Then you would have to simplify that. You'd have to take the square root of both sides. So you get a is equal to the square root of 1,682. You'd have to simplify that square root, and then you go back here, same steps as we did before, and put it in and get to the perimeter to there. Honestly, this is the reason why we memorize these formulas, because even though you may not like dividing by radicals, that there be easier than trying to figure out how to simplify square root of 1,682. If you have a calculator that will simplify that for you, hey, there you go. If you have a permitted calculator that will do that, that's great. But otherwise, if you're having to do this the more manual way, then that is that's a booger to try to figure that out. So remember, if we remember these formulas like that, they can make things a lot easier for us, because I wouldn't want to be staring that in the face of having to simplify that and then figuring out, okay, so that's 29 square root of 2 on both sides. Add them up, you get back to the same place. It just takes you longer. But both ways will work. Number 26. Oh, this problem. My least favorite out of all these. It's a puzzle problem, but I don't think it's totally fair. Anyways, in the xy plane, a parabola has vertex of 9, -14, and intersects the x-axis at 2 points. The equation of the parabola is written in the form y equals ax squared plus bx plus c, where a, b, and c are constants. Which of the following could be the value of a plus b plus c? Okay, just get this out of the way. The reason I don't think this is fair is because it says which of these could be the value. This problem has to be solved by plugging numbers in. Has to. You have all these steps you have to do beforehand, all this knowledge you have to have, but at the end of the day, you have to plug these numbers in and see which one. Which some may argue when they say which of the following could be the value, it's suggesting you have to plug things in. I don't know. This to me, it made me think of like which of the following is a possible solution is what made me think. Maybe I'm just looking at it wrong. But I don't know. I think when you're on problem 26 and it's a complicated puzzle problem, you should be able to solve it mathematically and not just let me put numbers in. Not that that's not to say that that's a bad strategy. A lot of times it's the best strategy, but this one, it's not an optional thing. You have to do it. Rant over. Let's get started on this sucker. Here we have this parabola. Let's do a quick sketch to just visualize where it is. So it's at 9. I'm not drawing this to scale. And negative 14. And it has an intersection of the x-axis at 2 points. So it's opening up. So what do we know about this thing already? We know it's a positive parabola. In that ax squared plus bx plus c, that a must be positive because it's opening up. Okay, how would I write an equation for this parabola? I don't have enough to write a full equation for it, but I can get started. If you use the vertex form, it looks like this. Okay, so the h and the k, those are the the h and k are the coordinates of the vertex. And a is the number that's going to end up in front of that x squared that determines whether this is a really skinny little parabola or whether it's very wide, however it looks. That determines the a. H and k are the vertex. And you can write any parabola in this format. So let's plug in the h and k. H is the x coordinate, that is positive 9. So I'm going to plug in a positive 9 for h. Don't get deceived by this minus and think, oh, it's a positive 9, so it should be plus. No, that minus is part of this formula. The h is all by its little lonesome. So it's a positive 9, so you plug in a positive 9 there, leave that minus alone. Out here, the k is negative 14. So I'm going to plug that in here, negative 14. And now I'm going to expand this. I'm going to expand this parabola so we can get to something that looks like this, the ax squared plus bx plus c. So first, and let me scoot that little 27 out of the way. And I'm going to erase this. We'll come back to it. We'll come back to it in a bit, this kind of idea of what the parabola is. But I'm just going to put a little sketch. So just remember that our parabola, it's something, it goes down and it goes up. So vertex is down here and it's opening up. Keep that idea in mind. Okay, to expand this first, I'm going to multiply this out. X minus 9 squared expanded is going to be x squared minus 18x plus 81. And you can do that by FOIL. You can write x minus 9 times x minus 9 and do FOIL. Or if you know the shortcut that says squares are equal to, it's going to be a squared plus 2ab plus b squared, where this is your a and that's your b. That's the pattern I use. If you don't have that pattern in mind, you can always use FOIL. It's fine. Okay, and the little a comes along for the ride, and then we have our plus a negative 14, which I'm going to write as minus 14. And this one's going to take a lot of writing, so I'm trying to give me some room here. Let's distribute that a throughout. So I get ax squared minus 18ax plus 81a minus 14. All right, so a, b, and c are constants, and this can be written as ax squared plus bx plus c. Okay, so what are my a, b, and c? A is just a. I'll write that down. My a is a. My b is the coefficient of the x, which is negative 18a. And then finally, my c is my constant, which is these two together, because a is a constant. So 81 times a is also a constant. 81a minus 14 is altogether a constant. So that's my c. Now they say, which of the following could be the value of a plus b plus c? So I need to add all of these together. So a plus a negative 18a plus 81a minus 14. All right, so if we have a plus a negative 18a plus 81a, you're going to get 64a. So 64a minus 14 is the same as a plus b plus c. Now, I'm asked to see which of these could be equal to this. Which of these numbers could be equal to 64a minus 14? Now we come back to this concept up here. This has to be a parabola that opens up because the vertex is below the x-axis, but it intersects the x-axis at 2 points. So a must be positive. If I set these was that. If I set 64a minus 14 equal to each of these in turn, and then I solve, in which one do I get a positive value for a? So now I have to go through and do each of these in turn. So you have to plug in. Again, plugging numbers in is often a totally valid technique and a strategy, especially when you're not really sure where to go. I'm just not, I think it's a bit meh to have on 26 have one where you have to plug stuff in to just try to muddle your way through it and not be able to just figure it out. Yeah, I'm still a little sore on this one. I don't know. I don't like it. I just don't like it. Okay, let's start with our first one, negative 23. If I add 14 to both sides, I'm going to get 64a on the left, and I'm going to get a negative 9 on the right. Now, as you can see here, that you might be able to jump ahead at this point, which if you can, that's great, because otherwise this is extra time consuming. Because look here, I have this negative 23, and I'm going to add a number to it, and then I'm going to divide. Because see, look at this point right here. When I divide both sides by 64, it doesn't really matter the number I get. Just know that it's a negative 9 being divided by a positive 64, so I'm going to get a negative value for a, which again, I can't have because it's a parabola opening up, so a should be positive. So what will we think go, what number should go here? What number does this have to be bigger than? If I'm going to add 14 to it, and it has to end up being positive, it needs to be small enough, or in this case actually weirdly big enough because it's a negative number, that when I add 14 to it, I get a positive number. So would negative 19 work? No, negative 19 plus 14 is still going to be negative. Would negative 14 work? No, negative 14 plus 14 is 0, and I need a to be a positive number. If 0 is up here, this parabola doesn't exist because then it'd be 0x squared. That's not a parabola. You know, we'd have a line. Like, no, it's a parabola. So D, negative 12, is the only one that would work, because if I put negative 12 in there, then negative 12 plus 14 is a positive 2. Thank goodness. And then A is going to be 2 over 64. It's a positive number. That's all we needed it to be, a positive. So D is my answer. Have I mentioned before I don't like that problem? Sorry, I have such a negative viewpoint against it. It rubbed me the wrong way. All right, moving on. Last problem. Well done. You made it. Number 27. Function f is defined by f of x equals negative a to the power of x plus b, where a and b are constants. In the xy plane, the graph of y equals f of x minus 15 has a y-intercept of 0 and negative 99/7. Oh, what a lovely fraction that is. The product of a and b is 65/7. What is the value of a? This isn't as horrible as it might seem at first glance. I admit, when I see these ones where they have negative 99/7, come on. But let's really look at what they're telling us. Okay, so we have f of x, and it's equal to negative a to the power of x plus b. And then y, which is equal to f of x minus 15. So I'm going to go ahead. I'm going to put this f of x in here, since that's what y is equal to. It's that minus 15. Okay, so I've got my negative a to the power of x plus b, and I've still got that minus 15. Okay. Now we're told that this has a y-intercept of 0 and negative 99/7. I don't really care that that's the y-intercept. I care that it's an x and a y value that I can plug in here, and it will be true. And I'm also told finally that the product of a and b is 65/7. Okay, so that's something else I know. I know a times b is 65/7. I'll leave that over here on the side for now. Then let's go back to our number and let's plug these in for x and y and see what we get. First, when I plug it in for x, well, actually, let's just put that weirdo negative 99/7 there for y. So weird. Then I'm going to put in 0 for my x. And this is going to work out lovely because any number to the power of 0 is just 1. So negative a to the power of 0 is -1. Hey, and now my a is gone. Isn't that lovely? When the a is gone, get rid of this from the last problem over there. I can clean that up. There we go. When we have that -1 plus b minus 15, and so now I have -1 and -15. I can combine those. So I just have b minus 16. Isn't that nice? b minus 16 is equal to -99/7. So, what a fraction. All right, so 16, I'm going to keep this in sevenths because this is one of those problems where you have to plug in your answer. So they're not going to accept a mixed number for my answer. It has to be an improper fraction or a decimal. So I'm going to convert that 16 into sevenths, that -16 into sevenths. 16 times 7 is 112. So this is -112 sevenths. So I'm going to add 112 sevenths to both sides. All right, and 112 sevenths plus -99 sevenths is 13 sevenths. Okay, so b is equal to 13 sevenths. And now this comes into play. A times b equals 65 sevenths. And I know now that b is 13 sevenths. And it equals 65 sevenths. And you can solve this in your calculator, or you can just do it manually here. To get rid of this 13 sevenths, I'm going to multiply by the reciprocal, and I do that on both sides. And I'm running out of room again. I always write too big. If you watch the channel, you know this about me. So let me write it a little more nicely. I'm multiplying by 7/13. So over on the left-hand side, all I'm left with is a, because those 7/13 and 13 sevenths cancel out. On the right side, those sevens cancel out, and I am left with 65/13. Or it could have canceled again if you happen to know that 65 divided by 13 is a 5. So I could have done that actually right here, 5 and 1. Either way, I am going to get to the fact that 65 divided by 13, or there, 5 divided by 1, is 5, which is my value of a, and that is my answer. Yeah, I bet you didn't think we were going to get to 5 when we start with -99 sevenths, but here we are, and you have finished! Woohoo! Congratulations! Hey guys, just a quick heads up, I've got some cool stuff coming for y'all, including a free course full of SAT tips and tricks, as well as an exhaustively complete course on everything you need to know for the SAT, both math and reading. So subscribe to the channel to get notified when that goes live. I'm also going to put it in the comments and description below as soon as it does. In the meantime, if this video was helpful or useful in any way, please let YouTube know. Comment, like, share, subscribe, you know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.